Hello students, this is Mr. Yao. In this lesson, we are going to learn more about linear equations. More specifically, we're going to learn to solve a specific variable in a linear equation. You actually have learned about linear equation before. That basically is y equals mx plus b. Okay, so we're going to learn more about that in this lesson. But first, warm up. Rewrite each quotient as a sum or difference. Well, first, let's understand the wording. Quotient. Quotient is just basically a fraction form, but we have variables in them, so it's not just fractions. That's why they're called quotient. And as a sum or difference, it's just basically asking you to rewrite these things into something plus something or something subtracting something. So first, for example, let's say you have like a 5 minus 2 over 2. You can actually separate the fractions into a 5 over 2 minus a 2 over 2. So it's asking to kind of do something very similar with these few questions. So let's have a look. First one, let's separate them. 4x over 2 minus 10 over 2. So you see, they share the same denominator, and I'm just separating them into subtraction. 4x over 2 is a 2x. Negative 10 over 2 is a minus 5. So that is being rewritten as a subtraction, as a difference. That's A. B. So the denominator is a negative 2, so I'm going to separate them into two fractions that both have the same denominator, negative 2. Which is 1 over negative 2, and the other one is a negative 50x over negative 2. The first part is a negative 1/2. The second part, though, that is a negative 50x over a negative 2, so they become positive. And 50x over 2 is just a 25x. And that is B. For C, well, since you currently don't have addition or subtraction, even though you do, but they're inside parentheses, so you have to distribute first, so it's just addition or subtraction. That's going to give you 5x plus 50 over 25. And then we can separate them into two fractions. It's going to be 5x over 25 plus 50 over 25. And in that case, we have 5 over 25 simplifies to be 1 over 5x, or you can write it as x over 5, they're the same. Then plus 50 over 25 is a plus 2. Now let's continue with question D. Same thing. The first part is going to become negative 1 over 5x, the whole thing over a 2 plus 5 over 2. The first part looks a bit complicated, but when you type this whole thing into your calculator, it's just going to be negative 1 divided by 5, and then you're going to the 2. That simplifies to be negative 1 over x plus 5 over 2, and that is D. Now let's move on to the next part. We have learned about linear equations before, and they come in various forms. The first form is the one you emphasized on last year, and that is the slope-intercept form. Y equals mx plus b, m represents the slope, and b represents the y-intercept. Okay, now we're going to expand your understanding to another form. But before that, you have also learned a slope formula. So m is your rise over run, or m is also your change in y over change in x. So y2 minus y1 over x2 minus x1. This year we're going to still work with your slope, but we are going to actually use more in the formula, not depending on the graph. And because of this form, we actually have a second linear equation form, and that is called the point-slope form. When we are given the slope and a point, not a y-intercept, we can actually write a point-slope form. And this actually looks very similar. So if you actually divide both sides by the x minus x1 over, that actually looks like the slope equation. So it's basically coming from the slope equation. So in this formula, in this form, x1, y1 actually is a point on the line. So you still need a slope, and you just need a point instead of finding the specific y-intercept. Then you have a point-slope form. We will learn more about that in later units. But for this lesson, at least you'll know the form, and we're going to convert them into slope-intercept form, or maybe we'll solve for x. Now let's get into the examples. Example 1 and 2. 1. Solve for x. Well, x is right here, so that means, let me copy it down, y equals mx plus b. That means the first thing, we need to subtract b on both sides. So we got mx still left on the right side, left side is a y minus b. And then this comes to something similar from the warm-up. Well, now we need to divide both sides by dm. And when we divide both sides by dm, we are going to divide them separately. So it's like writing a difference. So in fact, divide, we are left with an x, and it's y over m minus b over m. So I can write it as x equals y over m minus b over m. That is example 1. Moving on, example 2. Solve for y. There you go. There's my y. So I need to subtract both sides by 8x to get rid of that. So we have by equals c minus a. Then we need to get rid of the b. We're going to get rid of them the same way. Whenever we need to divide, we are going to divide things separately. So divide both sides by a b. We got y equals c over b minus ax over b. You can also choose to write it as negative a over b and leave the x outside. They're the same. Okay, there you go. That is example 2. Moving on, example 3. Put it in slope-intercept form. So slope-intercept form, let me just remind ourselves, is y equals mx plus b. So in other words, you are actually trying to rewrite solve for y. Okay, so y minus y1 equals mx minus mx1. Of course, when we see parentheses, we're going to distribute. And then, you see, we have the y1, so we're going to add y1 on both sides. We have y equals mx minus mx plus y. So that's solving for y, which is the slope-intercept form. But now you might be like, wait, but what is our slope and what is our y-intercept? Well, let me write the form on the bottom, mx plus b. So you see, mx is the same. So m is still the slope, but the b is a bit more complicated. This whole thing is actually our b. So b is negative mx plus y1. So that looks a bit complicated, but that's why this is the slope-intercept form. Moving on, example 4. Solve for x. First thing, get rid of the 4y on both sides. Remember, we only got rid of the 4y, we didn't get rid of the negative sign, so it's still going to be negative 3x equals 5 minus 4y. And now I'm going to divide both sides by a negative 3. Remember to divide them separately. But whenever you divide them separately, you do need to be careful with the negative sign. That is gone. X equals, that's a 5 over negative 3, which is a negative 5/3. And then, next part, it's actually a negative 4y divided by a negative 3. So the negative signs would cancel. So we have a positive 4y over 3. Or again, you can write it as 4 over 3y. They're the same. That's example 4. Moving on, example 5. Solve for y. Well, we see fractions. Whenever we see fractions, we should actually try to do the same thing, which again is called to clear the fractions. Just like you were solving equations. This technically is still an equation, has an equal sign. So that's a 1/3 y, or in other words, the y over 3 plus x plus 7 equals 7. So it is basically x over 1 and 7 over 1. So we are going to multiply everything by the common denominator, which basically get rid of the divided by 3, so you're only left with a y. We have y plus 3x equals 21. So we need to subtract the negative 3x over. We got y equals negative 3x plus 21. So you see, solve for y actually means the same thing as put it into slope-intercept form. And this is the slope-intercept form. Okay, example 6. Put it into slope-intercept form, or in other words, solve for y. So let me copy down. 2x plus 4y equals negative 12. So we can actually subtract the 2x over, so we're only leaving the 4y on that side. We have 4y equals negative 2x minus 12. Even though it should put negative 2x on the back, but since we want the slope-intercept form, which is, again, y equals mx plus b, I'm putting the x in the then we're dividing everything by 4 separately. And this is also because it's asking for slope-intercept form, so the x and the number on the back should actually be separate. That's why we're not dividing the right side altogether. So the 4 is gone. Y equals negative 2x over 4 is a negative 1/2 x. Negative 12 over 4 is a negative 3, which means the slope is negative 1/2 and the y-intercept is negative 3. That is example 6. Moving on. Example 7. Put it into slope-intercept form. So let me copy it down. 2 minus 2/3 y equals -7/8. So we see fractions. Again, the first thing we should do is to clear the fractions. Let me write that phrase down again. Clear the fractions. Whenever you have an equation and you have these fractions, you should always think about that. So we need the common denominator. That's a 2/1. So we're finding the common denominator for 1, 3, and 8. But the 1, we don't have to count it. So it's just the 3 and the 8. The common denominator is 24. So we are going to multiply everything by 24 first. 2 times 24 is 48. Negative 2/3 times a 24 is a 16y. And then negative 7/8 times a 24 is a negative 21x. I'm going to keep solving, so subtract 48 on both sides. We got negative 16y equals negative 21x minus 48. Then we need to get rid of the negative 16, so we're dividing everything by negative 16 again separately. We're left with just a y. Let's be careful with the signs on the right side. It's a negative 21x over a negative 16, so that becomes a positive 21 over 16x. And then it's a negative 48 divided by a negative 16. That is a positive 3. There we go. That is example 7. Next, example 8. Put it into slope-intercept form, which means we're trying to get y by itself. But the right side, we do need to distribute first. So y plus 7 equals 2/3 x minus, that is a 2/3 times a negative 4. So it's a minus 8/3. For this one, we do not have to specifically get rid of the fractions because the y is by itself. So we just need to subtract the 7 over. So that y equals 2/3 x minus 8/3, then minus a 7. Well, you do need to combine the like terms. So y equals 2/3 x, negative 8/3 minus a 7 is a negative 29 over 3. And that is the slope-intercept form. The slope is 2/3, y-intercept is negative 29 over 3. That is example 8. Last two, example 9. Very similar to example 8. So let's distribute first. Y minus 1 equals negative 1/4 x. Negative 1/4 times a 2 is a negative 1/2. I just need to add 1 on both sides. We don't have to get rid of the fractions in this case because again, the y's are already by itself. So the y is already by itself. So y equals negative 1/4 x minus 1/2 plus 1. Let's combine the like terms. Negative 1/2 plus 1 is going to be a positive 1/2. So y equals negative 1/4 x plus 1/2. The slope is negative 1/4. The y-intercept is a positive 1/2. Lastly, we copy it down. 0 equals x plus 20 over 7 minus 4 over 7y. In this case, y does have a fraction attached to it, so we do need to actually clear the fractions. Over 1, the common denominator in this case, 177, is just a 7. So we're multiplying everything by 7, including that 0. Okay, so 0 times 7 is still a 0. X over 1 times 7 is a 7x. 20 over 7 times the 7 is a positive 20. Negative 4 over 7 times the 7 is a negative 4y. And then our goal is to get y by itself. You can choose to move the 7x over and the 20 over so that the y by itself, or you can actually move the y. So let's do that. Add 4y on both sides. We got 4y equals 7x plus 20. So the y is by itself. And sometimes this may be easier. It's just to move the y. So the y is already just on one side by itself, just with a number. Now we need to get rid of the 4. So divide everything by 4 separately. Y equals 7 over 4x plus 20 over 4 is a 5. Slope is 7/4. And the y-intercept is a 5. And that is example 10. That is everything for this linear equation lesson. Thank you.